So this is our last lesson in the probability and statistics unit. It's going to be really similar to the last lesson. And just a note before we go into this, especially with COVID-19, you'll hear things about different medications and whether or not they're helping people. And you might hear things like there was a difference, but it wasn't statistically significant. Basically, when they're testing different types of medicines, there might be a slight difference, but if it doesn't go outside of the normal differences that happen by chance, right? Like, some people are going to get better more than other people. If you had two groups of people, there might be a slight difference just by chance. So all of this comes down to these type of statistical tests. Other examples, and we'll see some here, if you do something called a poll in an election, that one candidate may look like they have 49% support and the other one has 51% support, but is that enough of a difference to know that if we did the entire population and not just this poll of a sample, is that a big enough difference to assume that the one candidate will probably win? So those are the types of questions that are answered. We'll see different examples here. So the first one is just basically about a die roll and seeing if we think the die is fair, kind of like the coin example we ended with in the last lesson. It says Aiden rolled a die 100 times and 25 of the 100 rolls came up as a 6. So this is his observed proportion. I'm going to abbreviate this since we talked about it last lesson. So the observed proportion, what happened, that's just the thing we're going to compare to our simulation, was 25 out of 100, which is 0.25. He wanted to see how likely a result of 25 6s and 100 rolls would be with a fair die. So Aiden used a computer simulation to see the proportion of 6s and 100 rolls. So something we talked about kind of, but I didn't make a big deal out of. Whatever he did for his observed proportion should be the same number of rolls for the simulation, just to kind of keep things consistent and have it be a true measure of how likely that thing is to happen in 100 rolls. He's repeating it 200 times. So each of these dots represents 100 rolls, and there are 200 dots here. Now, we actually don't have to calculate confidence intervals in this one. This is going to be more visual. So it says, based on the results of the simulation, what inference can Aiden make regarding the fairness of the die? So here, what we're going to do is we're just going to take his answer, 0.25, and I look, and if I think about a 95% confidence interval, 0.25 happened once, but it's not very likely, right? So down here it says, since the simulation shows, and we would choose few cases, this is many cases or few cases, with a sample proportion of, this is the number we're checking, right? So we just put our observed proportion there, 0.25, or now this part's kind of new. We're actually going to look in what's called the tail. So if we're on this side of the data, we're going to say greater. And if we were comparing something like maybe we got 0.12, we would say or less. So we're going to a side. We can conclude that the die is quite possibly not fair. Since he really wasn't, didn't happen very often on this chance simulation, what happens by chance when I made a computer do a bunch of situations like this, we can assume that it's quite possibly not fair. On these, you will never say something is definitely not fair, okay? Or definitely going to happen, because it's all chance, it's all probability, right? Weird things can happen on one sample. So it's usually going to be something like quite possibly, likely, words like that are what you should be looking for. Okay, so here's an election example. It says there's an upcoming election for student council president at a high school. Candidate A must get over 50% of the vote to be elected. A poll was taken, a random sample of 80 students from the high school, and 36 students, so here's our observed proportion, 36 students said they would vote for candidate A. So that's 36 out of 80, and if we type that in, that's going to give us 0.45. Okay, so if you didn't know anything about statistics, you might say candidate A is definitely going to lose. okay? But is 0.45 close enough to the 50% that we're not really sure, right? You know, it's just a sample. We didn't ask everyone in the school. So we use the simulation to figure that out. So simulations were done with a population percentage of 50%. So they used a computer program, assuming 50% to see what happened when they did random samples. Sample size of 80 to see how likely a sample of 80 would have 36 who preferred candidate A. The results of 100 simulations are shown below. So I'm not going to write it, but I think we get the idea, right? Each dot represents a sample size of 80, and there are 100 dots. What conclusion can be drawn regarding the likelihood that candidate A will win the election with more than 50% of the vote? So here's my 0.45. So here, there's a whole lot of them that are around that area, right? Definitely within the middle 95%. So this shows many with a sample proportion, in many cases, I just want to have the wording correct, with a sample proportion of 0.45, 0.45, or, sorry about my voice, fewer, right? Because we're on the left side here, so we're going towards this tail. So the results of the survey, right, we don't know. Maybe he'll win, maybe he'll lose, right? We weren't far enough on the side to say that he's likely to lose. Okay, so this, if you looked at the choices, this would be our inconclusive, right? So we don't really know who's going to win. So for the last two, I'm actually doing them from Delta Math so you can see the choices. It's a little bit more annoying because you can't see the whole problem at the same time, but we'll try it this way too. So this is also an election question. It says there is an upcoming election for student council president at a high school. Candidate A must get over 50% of the vote to be elected. A poll was taken of a random sample of 100 students from the high school, and 61 students said that they would vote for candidate A. So my observed proportion is 61 out of 100. This is equal to 0.61. So basically a simulation was run. This is based on 50%. So if you took samples with a population percentage or proportion of 0.50, what would happen if I kept taking samples of 100? Here are the results. My 0.61 falls right here. So this is a little borderline. There are 200 dots here. So we're going to say that this 0.61 or greater is few cases. So with the drop-down menus, since the simulation shows few cases with a sample proportion of 0.61 or greater, right, because we're in that tail. Now, since there was 0.61 or greater, it kind of made it out of that middle stuff that happens by chance. So let's just look at the options. We can never say candidate A will definitely win or definitely lose, okay, because it's all chance, right? This is probability, statistics. Since the number is greater, it looks like she's out or enough above 50% based on the simulation that she will most likely win. So we would submit our answer. Yes, and that's correct. So we're going to look at one more example. So this last example is about a senior trip. It says the senior class president of a large university claimed that 65% of the senior class was interested in going on a senior trip. To test his claim, the senior class president conducted a survey of a random sample of 50 seniors, and 29 said they wanted to go on the trip. So here's our observed proportion, right? 29 out of 50, which is 0.58. So not 65%, but that doesn't mean if you asked all the seniors, it wouldn't be 65%. Is this 0.58 close enough that we can assume that the 65% is reasonable? That's basically what we're doing. So we're on a simulation, important information. This simulation is based on 0.65. So if we were doing it by hand, that would be a bag of chips where 0.65 were peach or whatever color you were looking for. But as I said, this is done by computers. It's simulated 100 times, so there are 100 dots down here. So we find our 0.58, which is right here. Okay. Now, not great, right? Like, 0.64, 0.65 would be a little more reassuring if that's what we got. But if I look at this, and I'm going to scroll down the page first just so we can see this, we do see that there are many cases. Okay, so there's a decent number of dots that are here or lower. If we think about 95% and kind of like cutting it off, like 95% might be there. This is within that confidence interval, which we talked about in the other lesson. So we would say that the simulation shows many cases, or enough cases. I don't know if many is the best word, but there's enough that are 0.58 or less, right? Because we're on this side of the graph, so we're going less. So the claim that 65% of the senior class wants to go on the senior trip is quite reasonable. Okay, it's never definitely true. It's never not true because this is all chance, right? It's possible to have a sample that comes out 100% or 0% because in the tiny chance that you picked in your sample, everyone that wants to go, everyone that doesn't want to go, even just by random chance. So the really only options are the middle two. But since the 0.58 falls towards that center, it is quite reasonable. Okay, so this is the end of our unit. The test that's going to be tomorrow, the next lesson, is going to be kind of on all the different topics we've done.